In this video, we're about to talk about the NOT operator in MATLAB. That is one of the logical operators we can use to operate on logical variables. This is part of our larger discussion of the logical data class. Let's kick things off right by defining a mathematical operation called negation. Remember from one of our previous videos, we defined something called a proposition as a mathematical statement that had truth value. Each proposition can be one of two things. It can either be true or false. Starting from that framework, we say that the negation of a proposition P, remember proposition P is a statement that has truth value, so P is either true or false. The negation of P is denoted as tilde P, so this is kind of a sideways squiggly mark, P. That proposition is called not P. So anytime we read the tilde P, we can read that as not P. The proposition not P is true exactly when proposition P is false. That gives us a rule to define when not P is true and when not P is false. Let's go ahead and look at a truth table for the individual values of P and not P. So let's suppose that the proposition P is true. We say that the logical value of true is 1. We said that not P is true exactly when P is false, and the reverse is also true. The truth value of not P is false when P is true. In other words, we're notting the true. That's a weird freaking verb, isn't it? Taking the complement of, swapping it, flip-flopping, inverting, I don't care what you call it. The point of the matter is we're turning true to false and false to true, just like a politician. In this situation, we say that not P translates a value of 1 into a value of 0. If I start with P equal to 0 and I hit P with the negation operator, that turns 0 to 1. So in this situation, let's go ahead and look at P equals logical of 1. Notice that is a logical scalar because it produces a 1 by 1 array with a logical entry for its value. If I now hit it with the not operator, which is just tilde P, notice MATLAB is going to flop, invert, change the logical 1 to a logical 0. This, of course, is a 1 by 1 array, so that is a logical scalar, which means this expression is stored as a logical scalar in MATLAB. We could, of course, look at a second example where we say Q is equal to logical 0. When I now take not Q, MATLAB is going to take the logical value and invert it. It's going to change it from false to true because the opposite of true is false and the opposite of false is true. In other words, the not operation flips the truth value of whatever proposition is underneath. Notice on both of these examples, we focused on logical scalars, but we said that the entire truth table of our proposition actually stores both the information in P and the information in not P. There's a faster way to report the relationship between a single proposition and some operation involving that proposition. So in this case, we're going to call this the short or abbreviated table. Notice in this table, the first column represents logical values of P. P can either be true or false because P is a proposition. When I then hit P with the not operator, I produce the exact opposite value. So if P is assigned a truth value of 1, not P gets a truth value of 0. On the other hand, if P is assigned a truth value of 0, not P gets a truth value of 1. Check this out. I can actually use MATLAB's logical data structure to capture the entirety of this truth table as a matrix. So let's go ahead and hit logical data and we'll store 1, 0. So now I know that P is a logical column vector whose first entry is 1 and second entry is 0. When I hit not P, that takes each individual entry and hits it with the not operator. So notice that changes to a logical vector 0, 1. Now I can do something really fun. I know what you're going to say, Jeff, it's been fun the whole time, and I agree with you. I can actually create a matrix where the first entries of the matrix are represented by the different truth values possible in P. And the second column of the matrix represents the truth values possible with not P. When I push enter, notice this output matrix, this logical matrix, which is a 2 by 2 matrix, represents the exact truth table that I wanted for the entirety of this proposition. In other words, I can store using MATLAB variables entire truth tables. One interesting statement that I should make here is a single proposition can have exactly one truth value at one time. The statement that's happening in this truth table is not that P is both equal to 1 and 0. The statement is if P is equal to 1, then not P is 0. On the other hand, if P is equal to 0, then not P is 1. In a later video, we're going to talk about the difference between the form of a proposition and the actual value that proposition holds in any one truth value assessment. Here in MATLAB, when we take advantage of logical scalars, we're looking at individual rows from a truth table. On the other hand, we can group together collections of logical matrices to form entire truth tables and give us a sense of how a particular logical operation operates on all possible values of the input. Now, of course, we've discussed the difference between scalars, vectors, and matrices. So far in this video, we've only seen examples with logical scalars and logical vectors. Let's see the not operator work on matrices to invert the logical values stored in a logical matrix. Specifically, a few videos ago, we stored this matrix, which is a 3 by 3 matrix, numeric data. We can check that it's numeric data by going into the workspace and looking at A. A is a 3 by 3 matrix. It is stored using the double data class. We could have also tested the state of this. So let's use the isA function, and we'll go ahead and test, is A a logical variable? No, it is not. Look, false. 0 means false. So MATLAB is telling me A is definitely not stored using the logical data class. Let's check the single double class. Is A a single array? In other words, an array stored using the single data class? Nope. How about is A stored as a double variable? Ding, 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 ding. So now I know that A is indeed a numeric array. Let's go ahead and clear. So here I have A is equal to this vector. Let's convert A into its logical equivalent. So now we know that the logical of A is going to be stored in a logical matrix, a non-vector logical matrix. In other words, a matrix that's definitely not a vector. In this case, it's a 3 by 3 non-vector matrix. Another way to interpret the locations of the ones in my logical matrix is to think about them as telling us where the non-zero values of my matrix A lie. If I were to now take the logical version of the matrix A and hit it with the not operator, what would happen is I would invert all the ones to zeros and all the zeros to ones. In other words, not LA must be San Francisco. Oh, I'm sorry. Not LA has location ones where LA has location 0. In other words, these are location of the 0 elements of the original matrix A. Let's go ahead and sum this up. The not operator in MATLAB is denoted using the tilde. To get to that on my keyboard, I go to the tab key. Right above, next to the 1, there's this little single quotation mark. I call that a chon or a ten in Japanese. And then if I push shift, that becomes a tilde. Notice if I hit that, that's exactly what I produced. That's called the not operator in MATLAB. So the not operator negates the stored truth values of any logical variable. For our logical matrix LA that came from the matrix A, when I hit not LA, everything that is a 1 turns to 0, and everything that's a 0 turns to 1. Indeed, when I execute this, notice all the 1s turn to 0, and all the 0 turns to 1. I'm not going to focus too heavily on this at this exact moment, but if I were to type in A of not LA, MATLAB would produce a list of all zeros, because what it's saying is go to the matrix A, go to the locations of everywhere where LA is false. That's what this is saying. And then print out the values. We'll see that in a future video, but hopefully you're starting to salivate to recognize some of the potential underneath this for array addressing. That leads me to my community challenge for this video. In the comment section below, answer the following question. Why would you want to use not operators in MATLAB coding? What would this allow you to do? One thing that I always say is sometimes students in my classes this quarter don't have good answers to this, but you might have a really, really compelling answer in a future quarter. One of the really cool things about YouTube is that you could actually comment back quarters later to future generations of my students. I really hope you'll consider doing this. One of the things I love about working with students is that you're so freaking smart. You have so many gifts to offer. My hope is that as you grow up, you'll share those gifts with the next generation that have to suffer through my classes. With that, I'll end this video. You can always post your comments and questions in the link below, and I'll see you in the next video.